Hi, this is Kate, and we're learning about scientific notation. Scientific notation is just a way to abbreviate numbers, usually really large or really small numbers. For example, this excessively large number is the distance in meters from Earth to the star Betelgeuse. Another really large number is the speed of light in meters per second. It's approximately 300 million meters per second. If we were to divide these two numbers, we have a distance divided by speed, it would give us time. It would tell us how many seconds it would take us to travel to Betelgeuse if we were moving at the speed of light. However, thinking about dividing these two numbers with all these digits by hand is kind of gross. So we're going to use scientific notation to abbreviate these numbers. First, we'll back off this problem a little bit so that we can just get a sense for how scientific notation works. Let's say you live here at this red dot. Your friend lives over there at the blue dot. That's about, on this map, 2,300 miles away. And let's say you have another friend who lives very close to you. She lives about 2 3/10 miles away, 2.3 miles away. How many times farther away does your blue dot friend live than your green dot friend? Hopefully you weren't thrown off too much by those exponents. 10 to the second power in choice B, that means 10 times 10. So choice B was saying 100 times farther away. Choice C is saying 1,000 times farther away, because it means 10 times 10 times 10. So if your friend lived 10 times farther away, he would live 23 miles away. 100 times farther would be 230. 1,000 times farther is what we wanted, 2,300. And then 10,000 times farther would be 23,000 miles away, which I'm not even sure it's possible on the surface of the Earth for something to be 23,000 miles away. But anyway, another way that we can write 2,300 now is we can say, well, it's 2.3 times 1,000, 2.3 times 10 to the third. And this exact format here is called scientific notation. We take a simpler looking number, 2.3, and we multiply it by a power of 10 to make it as big as we want. A shortcut in our number system, when we multiply by 10, since we work in the decimal system, in the base 10 system, when you multiply something by 10, it's equivalent to moving the decimal point one place to the right. So if we multiply by 10 to the third, we move it 1, 2, 3 places to the right. That's equivalent to 2,300. So let's see how we can use this to figure out our time to travel to the star Betelgeuse. Well, this 6.072 with a ton of zeros after it, that's equivalent to 6.072 times 10 to the 18th. I would have to move that decimal point 18 places to the right to get my number in regular form. Can you figure out which expression is equivalent to 299,800,000? The equivalent expression is choice A. If we took 2.998, move the decimal point 8 places to the right, we would have our 299,800,000. So how does that help us divide these two numbers? We can simplify this left-hand portion just by popping it in a calculator. This is equivalent to 2.025. Then we need to divide 10 to the 18th by 10 to the 8th. But you should recall a shortcut. If you're dividing expressions with the same base, there's a shortcut for what you can do with the exponents. The shortcut is to subtract the exponents. 10 to the 18th divided by 10 to the 8th is 10 to the 10th power, because 18 minus 8 is 10. So it would take us 2.025 times 10 to the 10th seconds. This is still a huge number and kind of meaningless, but we could convert it. I've already done that for you. This is equivalent to about 642 years. So now you know. We can also use scientific notation to abbreviate really small numbers. Can you tell me, what would you have to multiply by 5 to make 5 100ths, 0.05? Well, 5 times 10 would be 50. 5 times 100 would be 500. That would result in a really large number. We want our product to be a really small number, so we're going to multiply it by something tiny, 1 100th. So 0.05 is the same as 5 times 1 100th. To write this number in scientific notation, we want to write this as a power of 10. So which power of 10 is equivalent to 1 100th? 1/100th is equivalent to 10 to the negative 2. Because remember, the meaning of negative exponents, 10 to the negative 2, means the same thing as 1 over 10 to the positive 2, or 1 over 100. So 0.05 in scientific notation can be written 5 times 10 to the negative 2. The moral of the story here is if we want to take a tiny number and write it in scientific notation, we're going to end up using a negative exponent. Negative powers of 10 get us really tiny numbers. Our shortcut for multiplying by powers of 10 was to just move the decimal point. We're going to move the decimal point 2 places, but we want a small number. We have a negative exponent. So in this case, we move the decimal point 2 places to the left to get our equivalent value. I just want to give you a heads up about the output of many of the calculators you're using. What I did on this particular calculator was I took 17 and I divided it by a really big number. This gives me a really tiny value as a result. I take 17 things and I'm breaking them into about 5 billion groups, so they're tiny. The result the calculator gives us looks like this. And I've known a lot of students who see that E and they think maybe it means error. They don't understand what the calculator is trying to tell them. The E actually stands for exponent. This calculator is giving you a result, but it's giving it to you in scientific notation. It's saying the answer is 3.31567 times 10 to the negative 9. So if you happen to see that result from a calculator, don't think the E means error. Think, oh, the E means exponent. This is the same as scientific notation. So let's see if you've been paying attention. Can you tell me which value 3.31567 times 10 to the negative 9 is equivalent to? Those negative powers of 10 correspond with really small values. It's the same as moving the decimal point 9 places to the left, so it's equivalent with choice A. We've seen how scientific notation can make dividing easier. Let's see how it can make multiplying easier. Here we're multiplying 4 times 10 to the negative 8th by 3 times 10 to the negative 7th. All that's going on in this problem is multiplying. Multiply, multiply, multiply. And we know when we're multiplying things together, it doesn't matter what order we do it in. Multiplication has what's called the commutative property. We can change the order and still get the same result. So I'm just going to rearrange these numbers to say 4 times 3 times 10 to the negative 8th times 10 to the negative 7th. 4 times 3 is 12. Can you think about your exponent rules, your shortcuts for multiplying terms with the same base? And tell me which one is equivalent to 10 to the negative 8th times 10 to the negative 7th. When you're multiplying expressions with the same base, you can just add the exponents. Negative 8 plus negative 7 is negative 15. So our product is equivalent to 12 times 10 to the negative 15th. Now this actually is not technically in scientific notation, because in scientific notation specifically, you can only have one digit to the left of the decimal point. So to finish it up here, I need to move this decimal point one place to the left. Now, if I was writing it in standard form, I'd want to move it 15 places to the left. So if I shove it over 1, that's equivalent to, okay, now I don't need to move it 15 anymore, I only need to move it 14. So our answer is 1.2 times 10 to the negative 14th. This is Kate, and we've been learning about scientific notation.